Hello there. Hope you're doing well. So today we are going to check how we can predict the survival of a single person that boarded on Titanic. So I have a data set which has these columns: survival, passenger class, sex, which is basically gender, the age, sibling or spouses, parent, children's, the ticket number, fare, the passenger or the ticket or the booking price, the cabin number of that person, and the embarked. Embarked basically means that when that person boarded on the from where that person boarded on the Titanic. So it can be these three cities or these three towns. I think they belong to England, if I'm not wrong, because I know this. This is a football club, so I think it's England. So you know what? Let's start. First of all, I'm going to import pandas so that I can read the my data frame, which is basically a Titanic dataset. So I'm going to declare a variable called df, which is going to read CSV, and that's CSV is named as train.csv. Here it is. So this is my node Python Jupyter notebook, and this is the dataset. So I'm going to read it, and then I'm going to check the head of it. So I just want to show you all the columns. So these are all the columns. So embarked S, C, and Q, as I said, these are three. And 1010, these are the counts. And then these are the survival. Survival are basically zero means dead, that person did not survive, and one mean that person survived. These are the IDs, these are the passenger classes. These are same, passenger classes are same as the economy class, business class, and all that. We have gender, uh, which is male, female, and age and name. So first of all, we are going to check the outliers or the empty data sets or the empty values in the whole data frame. So first, let's check the total. Sorry, is NA basically means all the rows that are empty. Show me all the rows that are empty. So I'm going to sum them, and it's going to give me all the rows that are empty. So for example, age has 177 rows that are empty. Cabin has 637. Embarked has 2. So we are going to predict the survival rate based on these columns that I'm going to mention. Survived is going to be our target. It's not going to be a feature. So passenger class will be your feature. Sex would be your feature. Age, sibling and spouse, parent, children, then the fare, and then the embarked. So we can drop cabin and ticket and name. We don't need them. So first of all, let's clear out the age, because as we can see here, that age has a lot of null values. So what I'm going to do is I'm going to declare the null values in age to the mean of the age of the whole column. So if I check the mean of the uh, mean of the age column of the data frame, it's 29.699 some values. So I'm going to assign the null values to this mean, right? So I'm going to copy it, and then what I'm going to do is data frame age dot fill na. It is a method, built-in method of pandas that they provide, and we can basically fill all the null values in the data frame with whatever value we want. I'm going to assign the axis of it to 1. I want to fill all the rows, not the columns. So I'm going to run this statement. Oh, I think something is wrong. One is no axis name. You know what? I think we don't even need this axis. Do it without it, if I'm not wrong. Yes, I'm going to use the in place. In place basically changes the original data frame, which is this one, right? So we want that, and once I run this, you will see that the uh, age column is now filled, and there is no null values. As you can see, age is complete. Then we have cabin. We can drop cabin. We don't need it. So we can either drop it or we can ignore it. You know what? We're going to ignore it. And then we have embarked. You know what? Embarked. We can drop these two rows, because embarked, uh, I don't think so. They will provide us much information. So you know what? We can drop it. So data frame dot drop. This is also another method where we can drop values uh, from the rows of the data frame. So what I'm going to do is I'm going to say subset. Wait, sorry, drop NA. It's drop NA. It's not drop. It's drop NA. Then we have subset. Which columns do you want to drop? In bar, right? And then the axis. Axis is what is the axis? Sorry, it's not axis. It's axis or is it index? Let me check. Uh, in place is equal to 2. Yes. Index. No, it's not index. It's axis. No. So you know what? Just let me just run it and check if it's working. So I'm going to copy this again and check if the embarked column is now is filled or not. So yes, embarked is also, and we, as we said, as I said that we are going to ignore this. We don't need it, so we are not going to drop it or anything. Just ignore it. Okay, so now we are going to perform the logistic regression on it. Logistic regression is basically classification. Classification meaning, for example, true, false, yes, no, zero, one. So it's kind of a binary thing. You can say that we classify something into either two categories. Like, for example, an email can be a spam or not spam, right? So there is no other option than that. So that's logistic regression. In our case, we are going to predict the survival, which can either be zero, which means he survived, he or she survived, or which can be one, which means they did not survive. So we are going to need all these columns. Let me copy these columns. You know what? I'm going to check the head again over here. Df dot head. Uh, so we are going to need these sets, right? And for a machine learning model, machine learning model does not cannot cannot evaluate its accuracy in all these things, cannot be trained on strings, on data that are strings. So as we can see here that this is a string, and then embarked is also a string, right? So our features are basically these are our features. Let me show you. Okay, so the features are basically the things that will allow us to predict the survive, that will allow the model to predict the survived. So those features are these. Let me copy all of them and then I will show you. Okay, just wait a moment. So this is the survive. This is the passenger class. We don't need the name. Name will be ignored. Yes, we need the sex of the person, which is the gender, and then we also need the age. Age is very important. Uh, because most of the young people, they, if I'm not wrong, they died on the Titanic, and the older people, they get to live. It's not some kind of humor or something, but it was just that out of respect they allowed the older people to go through their to get out of the ship first, and the young ones, they were left. So these are the columns that we need. Now as we can see, a passenger class, it's an integer. Okay, sex, not an integer, we have to convert it. The age, it's an integer. Okay, sibling, yes, integer. The parent children, yes, integer. Then we have fare, yes, integer. Embarked, no, it's not integer. As we can see, it's a string, SC or Q, which are three towns. So what we are going to do is we are going to perform the one hot encoding. What is one hot encoding? One key hot encoding is basically converting the like, for example, gender can be, if I say is male, right? It can be either 0 or 1. Like, for example, someone can either be male or female. So in this case, if I say is that person a male, and then the answer can be 0, which means no, and the answer can be 1, which means yes. And then for the embarked, what we can do is we will have C, Q, and S. And then, for example, there is someone who boarded the ship from the Southampton, right? The S. So what we are going to do, we are going to provide the value like this: 0, 0, 1. So what this basically is, like a logic gate, right? So C0 means he did not started his journey from C, which was a town. From Q, no, he started his journey from S. So this is basically the basic concept. If you don't understand it, you can search on the one key hot encoding. Or so the Panda has built-in functionalities to do this. So what we are going to do is we are going to say that where is it? Where is it? Yes. So we are going to assign the, you know what? Don't assign it right now. I'm going to say get dummies. Get dummies is a function in Panda which basically takes a data which is our df, and then it takes I think columns, if I'm not wrong. Let me check it. Yes, columns. So I would say columns. Columns would be my first column that I'm going to check is age, right? So if I run this, as you can see that no, 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 it's not age. Sorry, sorry, apologies. It's not age. Why am I doing it on age? It's sex. Yeah, it's not age. That's why it's giving me a very long line, as you can see over here. So apologies. It's age, right? So it removed the sex, which was basically here, as you can see. Here the sex was, it removed it and it converted it into two categories, sex female or sex male. So sex can either be, so for example, the first person, which was Mr. So Mr. basically means a male person. So that's why it's saying sex is male. So let's see a female example. So here it is a female. So no, it's not female, it's male. You know what? Let me check this one. This is female. So as you can see, miss. So this is basically the concept of whole key hot encoding. So what I'm going to do, I'm going to drop the first one. So drop the first one basically means that it will drop this column and it will only mention this column in the data frame, or only this column will remain in the data frame, and this column will be dropped. So because we don't need it, so sex male, which basically will be 0 or 1. You know what? Let me show you. Okay. So here, so we dropped the first one, which was sex female. So sex male is only there. So is Mr. Owen has a male? Yes, 1. Is Mrs. John Bradley a female? Yes. So it says that, you know what? Sex male is 0 because she is a Mrs. And for example, this one, Miss Lina. Sorry, I cannot pronounce these names as I'm not familiar with them. So Miss Lina. Miss Lina is also a female, so that's why it's mentioned 0, that she is not a male. Now here, Mr. William Henry. So it is a male, as we can see it. So that's why it's giving us true. So that's the basic concept of it. And you know what? I'm going to say data frame. So data frame will be assigned to it so that we can renew it. And then we are going to do the same for the embarked. Embarked will have basically three columns, as I said mentioned earlier, that it can either be C, Q, or S. So that's why it will have three columns. If I run this, and now if I say dot, uh, you will have a different kind of data frame. So the sex is gone, embarked column is also removed. Embarked column is converted into either Q, S. So you know what? Not going to drop the first one of it because we have three, right? We don't not have two or something like that. And it will give me an error. Why? Because the embarked column was already dropped. So that was a stupid kind of mistake that I did there. So I'm going to run all of the code again so that the embarked column comes up again. And yes, so it's removed. If I run this, as you can see that embarked is either C, Q, or S. So this person boarded from Southampton. Then we have this person, which is Chittagong. I don't know what C stands for, but from this town. Then this guy is also from this town. This guy is also from this town. And this is basically the concept of the one keyword encoding. So now what I'm going to do is I'm going to start the process of the machine learning, which was basically training model and fitting data and all that stuff. So I'm going to import from sklearn. So if you don't have in scikit library, you can search for scikit-learn library, and you can find a lot of details about it on the Google. You can install it using pip install and all that thing. If you go to the installation guide, you will see that there they gave you this command you have to run. I already have installed it, so I'm not going to do it again because it takes some time, because it will install all these packages, which is a very long process. So I'm not going to do it right now. So from sklearn dot model selection, no, it's not model, it's linear model import logistic regression, right? So this is basically logistic regression. You know what? I'm going to do it on the next line so that you guys have the idea of what our data frame really has. I'm going to keep this as same. I'm going to paste it here. Sorry. And then I'm going to declare a variable called model regression. Sorry, model. And then I'm going to assign it to logistic regression, right? So here what I'm going to do is the data that we have here is combined, right? If I check it, df dot df dot who dot info, right? So if I check the info of the data frame, it has over 800 890 total rows. So for machine learning, it doesn't need all of the rows. It needs at least 30, 70. 30, 70, basically 30 will be for the testing purposes and the 70 would be for the training purposes. So it needs to separate the data so that it can train on some data and then test on the other data. So sklearn, the scikit library has this function called train test split, which splits the data into train and testing data sets. So what I'm going to do is I'm going to declare the x train, right? The x test, then we have the y train, right? And then we have the y test, right? And before we do that, we did not separate it. I think I forgot to separate the data into, that we were doing this step and we did not do it. I think that's kind of, I don't know, I missed it, how I missed it. So basically, first of all, we're going to do this one because we need the data. Uh, we need, the model need training data, the features and the target variable. So our target variable is the survived, right? And for the, where is it? Yes, for the, you know, for the features we have, these are the columns that we have: passenger class, sex male, age, siblings, spouse, parent children, fare, and the embarked. And as we said, the embarked has been distributed into three different columns. So I will copy them and you will know why I'm distributing these columns once I start testing this model. But first of all, I'm going to do this and embarked queue, and then we have embarked S. So this is basically our features, right? Feature of one single person. For example, one single person on that ship have a class, gender, age, sibling, and all these things. And then we have the target. What is the target? Target is basically the things that we want to determine or that we want to find out. So that is survived. We want to find out how many does a person with these features survived or not. So that's what we want to find out. So these are basically the two columns. So anyways, I'm going to do this. We have split it. Thank God I remembered it. I did not remembered it. So it will take the features and then the target, and then we will have the test size. So I'm going to keep the test size as 0.3. So this basically, we have 100% of the total data, and then it will convert 30% to testing purposes, right? For the testing purposes, and then the 70% would be used for the training purposes, right? So we are splitting that data into 30, 70%. You can do any kind of thing like 5 or 25, 24, or any you can use anything, but this is the most common where people do 30, 70. And then we have a random state. So random state basically selects data randomly throughout the separates data randomly throughout the data set. So I would keep it as 42 is a very common digit that people use, so I'm going to use it. After that, I have done all that. So I'm going to fit the model, the training data model dot fit, and then I would fit it the X train, which is the training data, and the Y train, which is also the training data. You know what? First, let me show you what these two have: X train and Y train. So X train has this data, which is randomly selected from the data frame, and then the Y is Y is just a series, right? So it's a series of one zeros, the survival rate. So I have parsed these two, and then as you can see that the model has been trained. In most of the cases, if the data is too much, then this is the sign that you will see that the total number of iterations have reached and all that. There's another method where you can use in here where you can specify that I don't want any kind of limitation for the iterations, and that will loop through all the data, which I don't remember right now, and it's not necessary, but as our model has been trained. And now let's check the predictions of the model, right? So model dot predict. We are going to pass the testing data set. What is our testing data set? X test. And if I check the predictions, it will contain zeros and ones, right? So for the first person, it predicted that he did not survive. Let's see. So this is the first person, and he's right. He did not survive. According to the features that this person has, it did not survive, and he's right. He predicted correctly. Now, we can also check the metrics of this function, like for example, the confusion matrix and the classification report. So I'm going to check the confusion matrix and the classification report, right? So let's see what we get. Classification report. And classification reports basically takes the true y values and the predicted y values. So we have the y values, true y values are here, y test, and the predicted y values are predictions, right? So as you can see, this model has these kind of features, and it has an accuracy of 79%. If you provide a more variable data or more kind of big data to it, or large data sets, its accuracy will increase a lot. So let's try the confusion matrix of it, which will also take the same two variables or the predictions or whatever you can call it, and it predicted 138, so it's better. The sum of these two variables, the sum of these two, 138 plus 172, should be greater than these two in order for your model to be accepted. If this is not the case, your model has failed, and it cannot be applied to real life cases. If the sum of these two is greater than these two, so your model can be applied to real world cases. But don't do that. Don't do, other than testing. If you want to test it, that's okay. But if you are deploying it to production or something, don't do it. Do it with the with your teams and all that. So let's test it. Let's provide a test person. Like for example, there was a person on the Titanic data set. Sorry, the Titanic, and he has these features. And that person that was on the Titanic has these features. So the passenger class of that person was one, right? So he was a business class passenger. And you know what, let's say he was a male, right? His age was, let's say, 25. He was 25 years old, and sibling spouse. Yes, let's say he had one sibling and one wife. So that would come two. So parent children, let's say no, he does not have any parent or children on the ship, and the fare that he paid was, let's say, $500, right? Because it's in a passenger class. Embark. See, let's say, what, that person boarded from the Southampton. So I'm going to provide zero to it. Now you understand that what I was talking about, the one hot encoding. So we cannot provide here like Q or A because model does not accept that. Zero, and then Southampton would be one because he boarded from Southampton, right? And now if I print this, it's a dictionary, as you can see, right? It's a dictionary, and our model need to accept data in this format. Where is it? In this kind of single row. So what we are going to do is we are going to convert this person data frame. We are going to convert it into data frame using the pandas function data frame, and then we are going to pass the person. Sorry, person. Now if I check the person df, it's a single row, a data frame with one single row, right? So now what I'm going to do is model, sorry, not predict. I'm going to predict the person's data, whether he survived or not. As you can see, there is no such thing as survived in this because that's our target, and model is going to predict it whether that person survived or not. He survived. Wow. So that's it. That's basically it. That's the model testing that we did over here. And here are the feature of that person, and based of these features there, the model predicted that the person with these features survived. Now there are a lot of other things that model have gotten wrong, or maybe this model accuracy is not as much accurate as the other because it is giving 79% something. But that's because that data is too much small, as you can see over here where I checked the info of it. Let me, where did I check it? I don't even remember it. So it was something close to like 890 or 800 something. So that's very small data. You need a lot of large data set, and for example, which has millions of rows, where you can distribute that data into 7 lakh into one into the training, and then the 3 lakh into the testing. So that would be a kind of data set that you would say, you know what, my model should predict accurate on it. And in that cases, your model will predict accurate. But in these cases, it may be right, it may be wrong. I'm not sure. So you know what? Let's change the age of this person to, let's say, 60. And yes, he had uh, 4 children. You know what? Let's say uh, he had one sibling and one spouse. That's okay. 3 childrens and one parent, right? And he paid, let's say, $200, right? And he was from the Queensland. I'm not sure it's Queensland or what its name is. And his passenger class was three, right? So he was from three passenger class. So which is economy, I would say. I'm not sure. So this is the new data set. You know what it predicted, that that person did not survive. It may be because the person's class was the third class or maybe the economy class, so they did not give him priority, although his age was kind of elder. But I don't know, I'm not sure how this model predicted it. But this is basically the prediction how model do. This is logistic regression, where you predict either zero or one, true or false, yes or no. So that's basically logistic regression. And yeah, that's it. If you have any questions, please let me know. I will provide the code. And if you need any extra details, let me know. Okay, thanks.